Welcome to part 2 in our series on favorable interconversions of carboxylic acid derivatives. In our last video, we looked at turning acid chlorides into anhydrides or esters or amides. In this video, we're going to look at turning anhydrides into esters or turning esters into amides. You can also turn carboxylic acid anhydrides into amides. But the mechanism's pretty similar to the mechanism of anhydrides to esters, so I'm not going to show that. You can look in your textbook for the details on that one. I will expect you to know how to do that, but okay. All right, so, but to keep this video not too long, I don't think it's necessary for me to cover that one. All right, so first we're going to look at anhydrides to esters, okay? So this is a carboxylic acid anhydride, and if I react that with an alcohol, I'll use ethanol as my nucleophile here. Acetate is going to act as my leaving group, and my product is going to be an ester, okay, ethyl acetate in this case, and then the byproduct is going to be a carboxylic acid. All right, so we have a different electrophile from what we've seen in the previous video, but the elementary mechanistic steps will be the same. So let's kind of review that with this reaction. If I can figure out how to erase, ouch, not kill myself. All right. All right, so the mechanism here. There's my acetic anhydride. And I've got my ethanol here, my nucleophile, my lone pair nucleophile. All right, and that lone pair of electrons is going to attack the carbonyl carbon in a nucleophilic addition step. That's our elementary mechanistic step. We make a tetrahedral intermediate. Shown here. That's a 3. All right, there's a lot of lone pairs here. Okay, don't forget those formal charges. All right, and now my leaving group is going to be this acetate. So I'm going to do a nucleophile elimination. Nucleophile elimination. Oh, that should be an L, not a T. All right, and that gets us to okay, this plus the acetate. Where am I going to put that? All right, I'll put it right here. Okay, that was our leaving group left. And then in our final step, that acetate can act as a base, and we can do a proton transfer right there. PT, and that'll get us to our carboxylic acid derivative, ethyl acetate, plus acetic acid. byproduct. All right. We could also do this mechanism, but instead of having ethanol, we could have an amine there. It would still be a nucleophilic addition, nucleophile elimination, and a proton transfer. The difference with an amine is we'd have a nitrogen here, and we'd be making an amide instead. We might have a different alkyl group depending on what the amine is. Okay, so I think you should be able to figure that out. So lastly, I want to show you how we can get from an ester to an amide. So we'll look at that example. All right, and since ethyl acetate is a pretty simple ester, I'm going to start with that. All right, so we can react ethyl acetate with an amide. I'll just use methylamine. Keep things simple to draw. And our product here is going to be an amide. CH3. All right, an amide plus an alcohol will be our byproduct, ethanol. All right. So we got an so we're going to get from an ester to an amide by reacting with the ester with an amine. All right, let's look at the mechanism of this reaction. All right. So there's ethyl acetate, my ester. And here's my amine. It's a lone pair nucleophile. It's going to attack the carbonyl carbon. All right, so this is a nucleophilic addition step. It's the elementary mechanistic step. And we form a tetrahedral intermediate. Like so. All right, then we're going to do a nucleophile elimination. So we're going to eliminate that ethoxide. Nucleophile, ooh, why do I keep doing a T? E-L-I-M. All right. And let's see if I can fit this all in here. Let's see here. So H3C. So we eliminate that nucleophile. But we still have a nitrogen that has a plus charge on it. All right. I'm going to put that nucleophile down here. All right. Ethoxide. And that's going to act as a base now. And we're going to do a proton transfer. And we're going to get to our carboxylic acid derivative, which is a secondary amide in this case, plus ethanol. All right, and that concludes this video on another couple favorable interconversions of carboxylic acid derivatives. Probably my next video will be on hydrolysis of carboxylic acid derivatives. So reacting them with water and breaking some bonds, and that's going to get us to carboxylates or carboxylic acids. All right, thank you for watching, and have a nice day.